Okay, combustion reactions. We're going to talk about some kinds of chemical reactions. Combustion, we've mentioned this one, something combining with oxygen, burning. Combustion reactions also emit heat, and they end up giving us a compound that contains oxygen. So the important one for us to remember is that if we have compounds containing carbon, hydrogen, and possibly oxygen, the products are always carbon dioxide and water. That's for complete combustion. Now, if you're burning something and you don't have an adequate oxygen supply, you could get carbon monoxide as a product. And that's what happens when people die in their homes because the gas heater wasn't ventilated properly or something, and the carbon monoxide builds up. But as long as there's enough oxygen, you'll always get carbon dioxide and water. And so that's something that you should remember. So this is a sort of question that could show up on the next exam. Write a balanced equation for the complete combustion of liquid C2H5OH. Didn't give you any of the other reactants, didn't give you any of the products, because combustion, that word, tells us what to do here. So I've been given this one reactant, which happens to be ethanol, C2H5OH. And it's written this way because then I recognize it as an alcohol as opposed to one of the other compounds that also has the same number of carbon, hydrogen, and oxygen atoms. And I'm told this is a liquid, so I can put L. What's the other reactant in combustion? Oxygen. O2. And what state does oxygen have? It's a gas. And then what are the products? CO2 and water. So CO2, carbon dioxide, is a gas. And H2O, what's the state of that? So at room temperature, it would be a liquid. But if we're combusting something, this is going to be hot. So this will be a gas. I won't try to trick you with that, but that's why. Did you have a question? As the other reactant?
Yeah.
Because that is the other reactant in a combustion reaction. Always. Combustion, by definition, is something reacting with oxygen. And so if you think about, like a candle burning or a piece of wood burning, what's required for it to burn is the oxygen in the air. It's not just air, it's the oxygen in the air. And so you can put out a fire by keeping the oxygen away. That's how a candle snuffer works. It's like a little inverted metal cup that you put over the top of the candle. Well, then the candle, the flame, burns up all the oxygen that is in that airspace, and then it goes out. The reaction stops. Pardon me?
3 key things to a fire, like oxygen, heat, and fuel?
Yeah.
So if you take out oxygen, it completely stops it.
Right, so for combustion, you need a fuel, and you need oxygen. And then, well, you really need a source of ignition. You need something to get it started. Because just ethanol and oxygen are not going to spontaneously combust. But once you get the reaction started, so yeah, heat. Because then the heat generated by the initial reaction keeps it going. Yeah.
There are some stuff that will.
There are things that will spontaneously combust, right? Because they get enough energy at room temperature to do that. Yeah, it is crazy. And other things that, seem real stable, like paper. Well, if you heat paper to a high enough temperature, it will spontaneously combust.
These reactions only contain carbon, hydrogen, and oxygen, nothing else?
The ones that you are responsible for only contain carbon, hydrogen, and possibly oxygen. There are lots of other things that combust, but then the products are not very predictable.
But they always have to have CO2 and H2O.
If the reactant is carbons,
Just for these
hydrogens,
reactions.
yes.
Okay.
Yeah. So you can burn aluminum, but then the products aren't going to be CO2 and water. Yeah.
So if it tells us that it's a combustion reaction, it'll always be the oxygen and the reactants are.
Yes. In Chem 1A, a combustion reaction is always a reaction with oxygen, and we're only going to ask you about carbon, hydrogen, oxygen containing compounds, so the products are always CO2 and water. And so you just remember it, because that's
So does that mean there's other types of combustion?
there are many other types of combustion
Right
reactions.
now
We're just learning this one. Yeah. Yeah. Okay, so we've got the equation, but it's not balanced. Let's just try inspection. Just start with carbon and see how that works. Because sometimes that works great, and other times we're like, oh, wait a minute. So I have 2 carbons on this side, and over here, how many carbons? I only have 1, right? So if I put a 2 in front of CO2, my carbons are balanced. And next I'd like to look at hydrogen. So don't forget this hydrogen here. So there's 5 here and 1, so a total of 6. And so over here, if I had 3 waters, then I'd have 6 hydrogens. And now we're going to cross our fingers. So I can put a coefficient in front of the oxygen here, and it won't mess up carbon and hydrogen. So I'm going to look over here. I've got 4 oxygens in that one and 3 oxygens in that one, and so that's 7. I'm like, oh no, it's an odd number, but look, there's an oxygen here. So I need 1 plus 6 equals 7, right? I need to get 7 oxygens on each side. There is 1 here, so that means I need 6 from this one, and so if I put a 3 in there, it's balanced. And if you're struggling with this, I would encourage you to get some gumballs or mini marshmallows or gumdrops or something and some toothpicks. And say, okay, this color is going to be this atom, and this color is going to be that kind, and this is going to be that one. And actually make this. It really doesn't matter if you connect it properly or not, but if you get 6 hydrogens, maybe those are white, and 2 licorice carbons and a red oxygen, and then over here you've got 2 oxygens, and then you're trying to make these. And actually play with them and see, oh yeah, these are the minimum numbers of each thing, so that I can take this apart and make this exactly with nothing left over. Any questions? So those were combustion reactions. Alkali metal reactions. Alkali metals react with nonmetals very vigorously. The alkali metals are very reactive. So alkali metals will react with halogens, fluorine, chlorine, bromine, etc. In this way. So 2 of the metal atoms reacts with 1 molecule and forms 2 formula units of the compound. This is a photograph of sodium and chlorine reacting. It gives off a lot of heat and sparks, and so the sodium and the chlorine react to form sodium chloride. Now, if you know, they're going to have to tell you what the reactants are. Write the reaction for sodium and chlorine. Well, they're going to combine to form a compound. We can predict the formula of a compound because we learned how to do that in chapter 3. Write the formula for the compound that forms between sodium and chlorine. You look at the predictable charges from the periodic table and you write the ionic formula. Reactivity increases as you go down the periodic table. So this is the reaction of sodium with chlorine. So we go down potassium, rubidium, cesium with chlorine would be even more violent. Yes?
So as we go down a column, the atoms get bigger, right?
Yes, they do.
So would they
So we will explain the periodic trends in, I think it's chapter 8. But we need to understand electrons first, and we haven't done that.
I just remember there
Yeah.
was a question on the test where it was like, oh, which one has the most amount of atoms? And it was
Ooh.
it was the same elements in a given column, and I was like, okay, this one's
Yeah, so that question give you like 10 grams of each element, and which one contains the most particles, or which one contains the least particles.
yeah.
And there you just have to identify, I think it was the most particles,
Most particles.
most atoms. And so then if you have equal amounts, you'll have higher number if each of the pieces weighs less. Right? So if I have a pound,
It would take more to add up to that number.
right. Yeah, so if I had a pound of gummy bears and a pound of miniature gummy bears,
Take more.
there would be more of the miniature gummy bears, right? Because they're smaller. But that it would be the same mass.
Yeah.
Yeah, so that's the idea with that question. Alkali metals also react with water. So they form a dissolved metal ion and hydroxide ion and hydrogen gas. And these are highly exothermic and can be explosive because one of the products is hydrogen gas, and hydrogen gas is flammable. So as we go down, they become more violent, and here we see potassium. You see sparks flying, and then the sparks ignite the hydrogen. And so this can be an explosive reaction. You may have seen YouTube videos where people throw sodium into swimming pools and stuff. And stuff like that, is potentially extremely dangerous. There have been students in high school chemistry classes that have been, maimed because the instructor said, don't put sodium in the water. And as soon as he leaves the room, they take the chunk of sodium and throw it in a sink of water, and the sink explodes, right? Because stupid kids.
What's the 2 M's? Should that?
So what are the 2 M's? That's an excellent question. So this M is just standing in for one of the alkali metals. It could be sodium, lithium, potassium, rubidium, cesium, any of them. And they're all going to form a +1 ion. And then there'll be hydroxide ion and water. Any other questions? Reactions of the halogens. These are the most reactive nonmetals. And here we have pictures of them. Chlorine is a yellow gas. Bromine is a liquid. It's this really deep orange color, but it vaporizes fairly easily, and so here we're seeing the bromine vapor. And then iodine is cool. Iodine's a solid at room temperature, but it sublimes very easily, and so you can see this purple gas. So halogens react with many metals to form metal halides. And so halide is taking the group name halogen and making it into an ion. So we take chlorine becomes chloride, fluorine becomes fluoride, halogen becomes halide. And so halide just stands for an ion in the halogen family. Halogens also react with hydrogen, and they form hydrogen halides. So it could be hydrogen chloride or hydrogen bromide. This is in the gas state, and so it's named as a molecular compound rather than as an acid. But if dissolved in water, combined with water, then those are acids. And then you can also have halogens reacting with each other to form interhalogen compounds, but those formulas are not predictable because it's not ionic. So write a balanced chemical equation for each reaction. These can be more challenging. They're less straightforward, but we'll just give it our best shot. The reaction between aluminum metal and chlorine gas. So they're telling us what the reactants are. So aluminum What do you think the state of aluminum is?
Solid.
It's a solid. And chlorine gas, so that's a gas, they told us. Is it a diatomic element? Yeah, it is. So Cl2. And what do those form? Well, this is a metal and a non-metal. What kind of compound would that be? It'd be ionic. So what's the charge on an aluminum ion? +3 because it's in group 3. And what's the charge on a chloride ion? -1. And so from their charges, I predict that the formula is AlCl3. Ionic compounds are generally solids at room temperature, and they have very, very high melting points. Think sodium chloride, table salt, right? It's a solid. Have you ever seen it melt? Not even on the dashboard of your car in August in Fresno, right? It's still just going to be salt. It will melt, but at really, really crazy high temperatures. So this is a solid. Then we have to balance this. I've got 3 chlorines here and 2 there. So I need to get it even on both sides, right? So if I put a 2 here, that gives me 6 chlorines on the right, and then I can put a 3 over here and have 6. And then what do I need in front of aluminum? A 2. See, that wasn't so bad. Reaction between lithium metal and liquid water. So lithium metal, that's a solid. And water is H2O because it's H2O and it's liquid. Now this is one that if I gave it on an exam, I would think of this as a challenging problem because this requires you to remember something specific about these types of reactions. The alkali metals react explosively with water because they generate hydrogen gas that ignites. That's the explosive part of this. So hydrogen gas is one of the products. And then the other. Well, if we take the hydrogens out of water, there's oxygen. And you might think, well, it's going to make lithium oxide. It's going to make lithium hydroxide. So it's going to make, and the way the book shows it is lithium ions and hydroxide ions. And those would both be aqueous. Dissolved in water. It's reacting with water. There's plenty of water around. It's dissolved in water. So one lithium, one oxygen, 2 hydrogens plus 1, 3 hydrogens, dang, and 2. This is a stupid odd even issue again. Well, if I made 2 of these, now I have 2 plus 2 is 4. And then I could put a 2 over here and have 4 hydrogens. But now that also affects the oxygens, so we got to check those 2 oxygens and 2 oxygens. That one's hard. This next one's doable. Reaction between gaseous hydrogen and liquid bromine. So both of these are molecular elements, diatomic. H2, gas, and Br2, liquid. Bromine is the only non-metal liquid element at room temperature. Br2, there we go. Well, these are both nonmetals. but we can predict the formula because hydrogen also forms a positive ion. And so this is going to make a covalent compound, but it's going to be an acid when dissolved in water. It's going to form ions. And so we can predict the formula based on the ion charges. So bromine, being 1 over from the noble gases, has a -1 charge, and hydrogen has a +1 charge. And so the formula that they're going to make is HBr. That's going to be a gas at room temperature. I would not expect you to know that. And then how do I balance this? I need a 2 here. Please let that be the last slide. Yay!